Welcome to Multi-GPU Training. This lesson is part of Module 06, Advanced Topics. Let's get started. Let's now look at Lesson 6.1, Multi-GPU Training. Here we can see the data parallelism. Let's now look at Overview. Here we can see the model parallelism. You have 2x NVIDIA Tesla, P40 GPUs. Let's use them both. Multi-GPU training can dramatically speed up your fine-tuning. Learn to leverage data parallel and distributed data parallel for 2-3x faster training with proper setup. Duration, 90 minutes. Difficulty, advanced. Let's now look at learning objectives. Here we can see the tensor parallelism. By the end of this lesson, you will understand data parallel versus distributed data parallel, DDP. Set up multi-GPU training on Windows. Configure unsloth for 2x Tesla P40s. Optimize batch sizes for multi-GPU. Monitor GPU utilization. Troubleshoot multi-GPU issues. Achieve 2-3x training speedup. Let's now look at multi-GPU strategies. Here we can see the multi-GPU setup. Let's now look at Strategy 1, Data Parallel, DP. Here we can see the deep speed stages. Here's the bash code for this section, starting with GPU 0, master. Pros, easy to implement, one line of code. Works on Windows easily. Cons, GPU 0 bottleneck. Master does more work. Not maximally efficient. Slower than DDP speed, at 1.6, 1.8x with 2 GPUs. Let's now look at Strategy 2, Distributed Data Parallel, DDP. Here we can see the gradient sync diagram. Here's the bash code for this section, starting with each GPU. Pros, maximum efficiency, JOT 2x speedup with 2 GPUs, scales to many GPUs. Cons, more complex setup. Windows support can be tricky, requires different launching method. Speed, 2.36 with 2 GPUs. Let's now look at Method 1, Simple Data Parallel, easiest. Here we can see the multi-GPU memory split. Let's now look at Unsloth with Data Parallel. Load model. Add LoRa check available GPUs, move model to GPU 0 first. Wrap with data parallel. Uses both GPUs. Let's now look at training with data parallel. Load data training args, adjust batch size for 2 GPUs, create trainer train, save, unwrap data parallel first. Let's now look at Method 2, Distributed Data Parallel, maximum speed. Let's now look at setting up DDP on Windows. DDP requires launching multiple processes. On Windows, use torch.multiprocessing. Create training script, train ddp.py. Initialize process group, set up DDP load model, add LoRa, move to correct GPU wrap with DDP. Here's the PowerShell code for this section, starting with Python train ddp.py. Let's now look at batch size optimization for multi-GPU. Let's now look at calculating effective batch size. Here's the bash code for this section, starting with effective batch size, shakshas per device, batch shosh size, x num chot jolpus x gar. Examples, configuration, per device, GPUs, grad, ac, effective batch, Satyams Sorasai, single GP, U4, 1, 2, 8, multi-GP, UDP 8, 2, 1, 16, multi-GP, UDDP 8, 2, 1, 16, aggressive in 12, 2, 1, 24, recommendation for 2x Tesla, P40, per device, batch G, size 8 or 10. Let's now look at finding optimal batch size. Load sample data, create dummy batch, try forward pass, success. Clear cache, find optimal batch size. Let's now look at monitoring multi-GPU usage. Let's now look at real-time GPU monitoring. Monitor both GPUs every 2 seconds. Here's the bash code for this section, starting with GPU name memory usage GPU util. Here's the bash code for this section, starting with GPU name memory usage GPU util. Let's now look at programmatic monitoring, usage and training. Let's now look at troubleshooting multi-GPU issues. Let's now look at issue 1, GPU 1 not being used. Symptom, only GPU 0 shows activity solutions. 1. Verify GPUs detected. 2. Check queue to visible devices not set. 3. Ensure data parallel wrapping. Let's now look at issue 2, CUDA out of memory with multi-GPU. Solutions. 1. Reduce per device train batch size from 8 to 6 or 4 2. Increase gradient accumulation steps. 3. Reduce max sec length from 2048 to 1024.4. Enable gradient checkpointing should already be on. Conservative multi-GPU settings. Let's now look at issue 3, NCCL error, DDP on Windows. Problem, NCCL doesn't work well on Windows solution. Use glue backend instead. Here's the Python code for this section, starting with dev setup DDP, rank, world size. Or use data parallel on Windows, easier, still good speed up. Let's now look at issue 4, uneven GPU utilization. Symptom, GPU 0 at 100%, GPU 1 at 60%. Cause, data parallel master, GPU bottleneck. Solution, switch to DDP or accept slight imbalance. DDP distributes work more evenly. Let's now look at performance benchmarking. Let's now look at benchmark script. Set up based on NUM GPU as load model on GPU 0 only. Configure training, train and time run. Benchmarks, calculate speed up. Expected results, 2x Tesla, P40, single G, PU, 1.2 steps chart second, multi-GPU, DP, 2.0 steps chart second, speed up, so 1.76, multi-GPU, DDP, 2.5 steps second, speed up, is 2.1 SE. Let's now look at multi-GPU training checklist. Here's the bash code for this section, starting with multi-GPU setup checklist. Let's now look at key takeaways. 1. Data parallel, TQL's easiest, 1 line, good speed up, 1.7x. 2. DDP, TQL fastest, best setup, max speed up, 2.1x. 3. Double batch size when using 2 GPUs. 4. Monitor both GPUs to ensure utilization. 5. Windows, plus DDP can be tricky, use glue backend 6. Quality stays the same with multi-G PU 7. 2x speed, so Archie's half training time. Let's now look at what's next. Multi-GPU mastered. Now learn alignment techniques. Continue to. Lesson 6.2. Direct preference optimization. Direct preference optimization. Let's now look at additional resources. PyTorch data parallel. PyTorch DDP tutorial. Distributed training guide. Unsloth multi-GPU docs. Your training is now 2x faster. Use that time wisely. That wraps up multi-GPU training. Well done on completing this lesson. See you in the next one.